Thank you. Just for clarification, I started doing all of this sort of thing when I was about 11. So I'm not that old, even with the 35 years of experience. So just wanted to clarify that point. Um, Hopefully, people can see my presentation right now, sharing my screen there. So if you can't, please let me know. So what I want to talk to you about today is a lot of different things. I want to talk through some of the research that I'm doing. I want to talk about the presentation of the material to the public, and I want to talk about, the experience of seeing an eclipse. This will be my third eclipse. I'm not counting partials. I'm not counting annular eclipses. This will be my third total eclipse. I've forgotten how many partials. So hopefully you'll enjoy some of this, and I'll try and make it as informative as possible. So this is not me being egotistical here. This is me saying, why should anybody listen to anything I have to say about the eclipse? And we've been running around. I say we because a lot of people here at Gannon have been helping me, marketing communication, putting me in contact with the media, putting me out there to help me with these things. We've been running around everywhere trying to talk to anybody who will listen about the message of what the eclipse really means. And especially the safety message, the message that, yes, it can be dangerous if you do it wrong, but observing the eclipse should be something you enjoy. And with a little bit of caution, you should just relax and enjoy the experience and see something that is quite a rare occurrence in any one spot on the planet. And as you can see, these are some of the things we've been doing. I've been talking to a lot of different news agencies. This is the spacesuit that I own. Back here is a mannequin that wears this spacesuit that we call Gus, who lives in my office pretty much permanently. Hardest working man at Gannon, who hasn't been home for about 2.5 years. On the right here, on my right at least on the screen, you can see me at the Mauna Kea Observatory with the Keck telescope in the background in a snowstorm in Hawaii. So when people talk about the disappointment of potential poor weather, I've already experienced the disappointment of potential poor weather of sitting in a snowstorm in Hawaii for 7 days. But what we really want to talk about here is more about the eclipse preparations. And as I said, we really want to talk to people about what is the safest way to observe the eclipse. Obviously, filters, not really staring at the sun, is a poor decision. Using eclipse glasses, using filters, doing this the right way so you enjoy it and you don't injure yourself. And we've been, as I said, talking to the media and distributing eclipse glasses to schools and to local groups and anybody else who has inquired to acquire a pair of these glasses we've been speaking to. So we've been distributing these, and I'll talk a little bit more about these glasses. They actually have a QR code on them that leads to our website. So that's caused a lot of people to actually come and see the information that we have. And we do have one of the most comprehensive websites that I've seen. A lot of places are just saying, talk to NASA, talk to AAS. We tried very hard to make a nice comprehensive website that talks about safety, that talks about the eclipse from an Erie-centric perspective, but also gives people a lot of information surrounding the eclipse in general. I'm also going to mention, as I said, some of the research that we're conducting about the eclipse. Excuse me. This is an anemometer here that we're placing across the country, a series of these devices, and I'll talk about a little bit about those. So before we do that, let's talk about what an eclipse actually is and what's actually causing this, just as a bit of a primer. So this animation here is showing you the sun at the center, and then you can see an orbit of the moon and the earth. And I'll show something very similar in a moment. And essentially what we're seeing when we actually witness a total solar eclipse is the moon basically moving between the sun and the earth and covering up the sun in the sky. And this does not happen every month. This happens rarely. You have to have the coincidence of the sun, the moon, and the earth being in the right positions, and making sure that the moon is essentially in the same position as the sun. These things happen every couple of years, actually. but for them to happen at one specific point on the Earth is quite rare. So I'll mention some of that shortly here as well. When we are talking about the shadow of the moon falling on the Earth, though, this animation is showing you a previous one that came across sort of Australia and Indonesia here. But what I really want to point out here is how narrow the shadow is. So the moon is there casting its shadow onto the Earth, and you can see that little black dot moving across the globe. That's the shadow. And it's a very, very narrow shadow. There is a wider shadow called a penumbra, which you can see a partial eclipse in, but that little black dot is the only place during that eclipse that you could see the totality. That's where the moon completely covers the sun. And the fact that it's so narrow is the reason why people have to travel to see this particular event. It is not a worldwide event. It's only about 100 or so miles across at any one time. So people do have to travel to that eclipse track in order to actually see it. But there is a point here that I have to make. That's all very well and good. But if you look at this image here, you can see the atmosphere of the sun shining out from behind the moon. The moon is not completely covering the sun here. So we can still ask a question, why doesn't the moon completely cover the sun up here? Why have we still got that tenuous outer atmosphere that gives us these spectacular total eclipses? So why do we even have these eclipses? And I'm going to show you some images here just for comparison. So some of these a little scientifically might be a little bit weird. So you'll never really see, say, a full moon next to the sun like this, and the big sign saying not to scale should tell you that this is not remotely correct. But I just wanted to compare these two sizes, that if you look at the moon, it's about 2,000 miles across here. You don't have to memorize the numbers, but I always say this to people in my classes. It's just a couple of thousand miles across here in diameter. If you look at the sun, that thing's 865,370 miles. All we care about is it's about 800,000 miles across there, or 900,000 miles across. It's the vague size that matters. So the question is, why does something that's 2,000 miles across fit over something that's nearly 900,000 miles across? So if we actually put the moon, the sun, and the Earth to scale, that little dot there is the moon, and that slightly bigger dot there is the Earth. And then the big orange thing, of course, is the sun. You can actually see there's some sunspots here that you could actually drop the Earth into. These are featured cold spots, features on the sun. So we're looking at a situation here where obviously the moon is a lot smaller than the sun. And you can kind of see them all in one image there, where you can only get a tiny bit of the sun on the same slide, essentially, when you're looking at the Earth and you're looking at the moon to scale. So why does the moon actually fit over this massive star? And this is a really nice point. I really like this. This is a cosmic coincidence, as I refer to it, because yes, the sun is about 400 times bigger than the moon. We can't doubt that. But the great part is that the sun is also 400 times further away than the moon. So it's 400 times bigger, but it's 400 times further away. And that means when we see them in the sky, the sun and the moon are about the same size. Now, this slide here, I've got to point out, if you ever see anything like this in the sky, something is seriously wrong with our solar system, possibly the rest of the universe. You will never see a full moon in a daytime sky next to the sun like that. I'm just doing this to show you the relative sizes. As astronomers, instead of worrying about the size of things in sorts of thousands of miles or thousands of kilometers or hundreds of kilometers, we tend to look at things in the sky and think about more how big is something as it appears in the sky. And if we look at the sun and the moon, both of them are roughly half a degree across. So as the moon appears in the sky, it should fit nicely over the sun. And it does. And people have been watching eclipses for a very long time. You won't see it quite like this. I'll show you a more realistic one in a moment. But in the sky, the moon fits beautifully over the sun. And this is a really nice cosmic coincidence that enables us to have these eclipses and be able to enjoy these kinds of events here on Earth. You'll see something probably a bit more like this. Still a little unrealistic in terms of the simulation here, but bear with me. So you'll see more of a big black disk because it is a new moon, because the sun and the moon are in the same direction. They have to be to have an eclipse. And you'll have this black disk moving much slower than that. Over a couple of hours, you'll see the moon moving over the sun and then taking over the sun and basically covering it up like this. So that's what we have. The sun is in one position over here, we have the moon, and then we have that shadow falling on the earth. If you're in this narrow dark bit here, then this is what we call the umbra. This is where you'll see your total eclipse. If you're in this sort of pale shadow here, which is a much, much bigger area, then a lot more people will actually see a partial eclipse. And it's that total eclipse that people really want to see. That's the rarity. Partial eclipses, as we can see here, much more coverage. People see these a lot more than seeing those totals that they have to travel to. Now, I've got to say about every picture that I show you, pictures don't do an eclipse justice, a total eclipse justice. So we can look at these pictures and we can say, you know, aren't they pretty? And people will say, well, we've got pictures of it. Why should we go see the real thing? This picture doesn't convey quite what you'll see in the sky. You really have to witness one of these things for yourself and go and see a real total eclipse and then come back and look at this picture. You'll look at this picture in a very clinical way and say, yes, that's a total eclipse. But you really have to experience it and see one of these things in the sky. And then you'll understand, if you haven't seen one, at least, how these pictures don't quite convey the experience of seeing the eclipse. They're very scientific, they're very nice to look at, but you know, they don't really tell you the whole story. They're not the great experience that seeing an eclipse will be. Additionally, if people do want pictures, a picture will never, you know, stand up to the experience of seeing it. As I said, people have been asking me a lot when I've been going on site doing loads and loads of talks lately. Can they use things like eclipse glasses and put them in front of their phone and take a picture? I wouldn't. I wouldn't risk damaging my device during the partial phases, and during the total phases, I would just stand and enjoy the spectacle and just forget taking pictures. If you want pictures, they'll look like this. I can't tell whether this one is, I know which one it is because I imported it to the talk, but you can't really tell the 2017 pictures from the 1999 pictures. The pictures all look very, very similar. And so I would say download a good picture of the eclipse and just stand on the day and enjoy the spectacle and enjoy the fact that you're there to see this total eclipse and not worry about trying to take pictures with your phone camera through a tiny little lens. It's not worth the hassle. So I've got sad news for anyone who's going to be around in 100 million years. The eclipses that we're experiencing here on Earth today, these total eclipses, will not occur forever. The moon is actually moving away from the Earth. It seems like a lot, 3.8 centimeters every year, but remember, the moon's huge. So it's moving slowly away from the Earth, and that means that eventually, over 100 million year timescales, you'll have a situation where the moon doesn't fit completely over the sun, and we'll have what we refer to as these annular eclipses. Similar thing occurred in Texas last year in October, where the moon didn't quite fit completely over the sun. And so the situation is that humans just happen to be on this planet at exactly the right time when the moon fits nicely over the sun for us to experience this particular phenomenon. So it's a really nice time to be on the planet, and it's a really nice time to see this effect while it exists. I realize that you're not exactly going to miss it, considering it's 100 million years until this stops occurring, but still, we happen to be here at the right place at the right time to see this kind of spectacle. So we've seen this slide before here where I've shown this animation, but it's worth keeping in mind what's going on here in terms of the size of this particular umbra, the size of this particular shadow as it moves across the Earth. The other thing I want to point out is that shadow, this simulation is not too bad in terms of its speed. That shadow is moving very, very quickly. And that means that you don't experience a very long totality, and you have to be in the right place at the right time to see your eclipse. And this is showing the actual track of the eclipse across the country. The 2017 eclipse took a slightly different path across the country and didn't hit so many major population centers. There's about 42 million people sitting underneath the line of totality, as we would call it, which is that really dark line there. And that line is going to come up through Mexico, through Texas, and then sweep up across the USA, and then exit up into Canada, and then over into the Atlantic Ocean. The speed of the shadow, as I said, is really quick. You're talking about thousands of miles per hour. Varies a little bit based on the directions, but you're talking thousands of miles per hour. And as I said, the umbra width, that's the width of the actual line you can see the total eclipse in, is only about 111, 112 miles across. So you have to be in the right place at the right time to witness this. And those of you in Erie, you are exactly in the right place and in exactly the right time. Here's something like you'd see. It's speeded up, so this doesn't take the whole 2 hours, but the moon will slowly move across the face of the sun and eventually take it all over, and then give you this spectacular view, which isn't quite in this simulation, where you see the outer edge of the sun, the corona that's usually blocked out from view. The entire thing, and I'll show you the timelines and show you the numbers, the entire thing takes quite a while. From the moment where the sun touches the moon, sorry, touches the edge of the sun, that starts at about 2:02 right here. And if you go out at 2:02, you won't even tell that there's an eclipse happening. Round about 3:16 here in Erie, you'll start to see that you've got your totality, you've got your total eclipse occurring, and then about 3 minutes, 42 seconds later, you'll have this flash, this diamond ring effect as the sun comes back, and then round about 4:30, once again, you won't even tell that anything had happened. So there's our data. If we happen to be in Erie for this eclipse, April 8th, 2024, as many, many people will have said by now, 3:16 p.m. if you're in the downtown Erie area. If you're in the local surrounding areas, it's still very, very similar. It's not going to change much. You have to move quite a distance to see a different time for your totality. About 3:16 p.m. is when it is safe to look at without glasses. I'll talk a little bit more about when that is safe and when it isn't. But at 3:16 p.m., you should be able to take off those eclipse glasses and then watch for about 3 minutes and 42 seconds. I would say don't watch the whole 3 minutes, 42 seconds necessarily. Be ready to get the glasses on 5-10 seconds before the end of the totality. But the totality itself is what people are here to see, and you can witness that without the eclipse glasses. It's all these partial phases like we're seeing on the screen right now. It's these partial phases that can be damaging to the eye if you sit and stare at them for a very long time. As we said, it doesn't always occur in the same place with a great frequency. So the last time Erie had an eclipse here, a total eclipse, was 1806. The next total eclipse in Erie proper will be 2144. So here in 2024, you just happen to be here in the right place to see it. There will be one that's south of here, very close in 2099, if you want to hold on for that one instead of waiting till 2144, however. But I would advise people go out, see this. You can see this from a backyard. You don't have to go very far if you don't want to. So this is from the 1999 eclipse, but essentially every eclipse will go through the same phases here. And we're seeing here that right over here, we're looking at just after what we call first contact, where the moon starts to come across to the edge of the sun and is starting its journey across the sun. And then slowly you can kind of see these changes in time. These time changes will be about the same as our eclipse, even though ours will start at about 2:02. but slowly the moon moves across the face of the sun until you see less and less and less of the sun. And some people say to me, well, I've seen a 90%, I've seen a 95% eclipse. It's not the same thing as seeing a total eclipse. The total eclipse is a different experience. So even if you are the kind of person who's seen a 95% and are wondering, should I go see the total? Yes, it is a different thing. So as the total eclipse approaches, you can see we're losing progressively more of the sun. And then we have what we call a diamond ring effect. And this is a flash on the edge of the moon here as it takes over the sun. And right after this diamond ring occurs, that's kind of your message from the sun to say, well, now you can actually look at it. And this is where you have your 3 minutes and 42 seconds of totality. And if you do have eclipse glasses on, you can't see this because it's just not bright enough. And during this totality, you will see planets coming out in the sky, the brightest one being Venus. You will see stars coming out. All sorts of things will happen, especially if you're around animals. They will lie down. They will think that it's nighttime and won't know quite what to do with themselves. During the 1999 eclipse, there were cows on our observing site that all sat down and then were very confused 2.5 minutes later, because that's the only that we only had 2.5 minutes of totality. They were really confused in 2.5 minutes time when the sun just came back and it wasn't nighttime. So if you are around animals, it poses no danger to them. The animals generally are too smart to look at the sun. So take a look at them, watch their behavior. It's very interesting. Then after our 3 minutes and 42 seconds, we'll get another flash, another diamond ring effect. And this is the signal that if you haven't put your eclipse glasses back on, get them back on by the time this happens. This flash signals the end of the total eclipse. And after that, you're really just watching the moon move across the face of the sun and doing in reverse what it did earlier in the day. So it's this totality is the thing that people want to see. That's the thing that people are really traveling for a very long distance internationally to come and see. So as I said, we're in Erie. We get our 3 minutes and about 40 seconds, depending where you are, 3 minutes 42 from downtown Erie. The shadow is going to come through our region like this. If you are between these two bars, this top and bottom bar here, then you will experience the total eclipse. The longest total eclipse, the longest totality, little more than 3 minutes and 40 seconds, is going to be right on this line here. So it runs almost through Cleveland, definitely hits Buffalo, but comes very, very close to Erie. And this is one of those things where people say they're traveling to Pennsylvania for the eclipse. What they should really say is they're traveling to Erie for the eclipse, because we are the closest, biggest population center to that eclipse, to the very center of the eclipse line. So if you really wanted to, if you wanted to experience the center line and get the absolute maximum time, then taking a boat out to the center of the lake is what you should, well, not quite the center, but taking a boat out into the lake near the Canadian border would be what you'd have to do. So on land, for Pennsylvania, Erie is definitely getting the best of it, and I would say is definitely the place to be for this particular eclipse if you're going to choose a destination in our state. Here's all the eclipses that are occurring in the future here between 2021, of course, 2040 here. Here is ours, our 2024 eclipse, and just showing you how this stacks up compared to everything else. So there's our totality moving across the country like that on April 8th. The next one, which I'm hoping I might have a successful enough research project this particular eclipse to send my research project out again. The next one is in 2026 over here, running down Greenland, Iceland, and into a little bit of Portugal and mostly Spain. And then the opportunity after that is 2028 in Australia. So you can see why people are excited about what they're calling the Great American Eclipse here. This is an event which isn't going to be repeated in America for a very long time, and you're going to have to travel quite a distance. All of these blue ones are total eclipse events, you're going to have to travel quite a long distance to actually experience one of these if you miss it. There are eclipse hunters, people who travel just purely to see these eclipse events. But if you don't want to spend the money or don't want to invest the time of going to a potentially politically unstable country to witness some of these things, then being here in Erie and going out and seeing it is an excellent choice. So that was the eclipse. That's what's going to happen. There's no stopping it. And when I'm planning for this eclipse and people say, well, relax, wait, there is no waiting. Nature is going to make this happen on April 8th of 2024, whether we like it or not. So I've been getting ready, not just in terms of my outreach, but also in terms of eclipse research. I started planning for this eclipse in 2017 when I saw the last eclipse, but started planning in earnest about 2 years ago in terms of our response to this event and in terms of putting our research together. The research is really just between myself and Dr. Nick Conklin, the chair of the physics department, who has done a lot of the engineering on this. The concept and the science is my side of things. The engineering was very much his, so I've got to thank him for that and his involvement. What we're going to do for the eclipse is look into an effect that's known as the eclipse wind. And this is an effect that people have been reporting for a very long time, actually, but only really positively detected at least once during a LiDAR experiment, which is a very complicated experiment during the 2017 eclipse. So there's only really one solid data point on this. So this is a really good experiment to try and conduct. The other great thing about this experiment is it doesn't matter if it's cloudy. It doesn't matter if it's raining. The only thing that could stop this experiment would be essentially a hurricane that knocks all our sensors over. So we want to find out if there's a wind set up by the shadow of the moon moving across the Earth. And people report that they feel a breeze or a light wind that occurs during the eclipse. And it's very inconclusive because the reports from people, we're not sure whether they're actually experiencing a breeze or psychologically, are they experiencing a drop in temperature? Because there is a significant drop in temperature by several degrees as the moon moves over the sun. You're blocking out the sun with thousands of tons of rock. So it does get colder. So it's sort of asked, is this a psychological effect or is it a real scientific effect? And we are looking at essentially radiation being blocked in a swathe across the country. And some of it is asking, is there a wind and is it set up from the sides? Is there a pressure wave that follows the eclipse across the country? We just don't know. And it's a really good question. So I decided to look into this. This is our lab, such as it is. We have coffee in there. We have soldering irons. We have all the things we need to keep going and work on these things. And on the bench there are what we call our total eclipse atmospheric sensor experiments that will sit on these tripods. There we go. And these will monitor the weather conditions at 7 individual locations all the way along the eclipse line. Well, actually 6 locations. We're going to have 2 in Erie, one as a control that we're currently finalizing the 7th one. But the others have actually been shipped out. I shipped them out last weekend to get them to all the various sites. And this is the prototype. So that piece of tape that's holding our light sensor on there is now a nicely molded component. So don't worry, we're not that crude. We didn't know if we'd have to move it in terms of its position. So the tape was a temporary measure. But on top of this thing, that black head that's on there, that's what we call a sonic anemometer. That uses little sound pulses to measure the wind speed, the wind direction, the pressure, the humidity, and the temperature. We have a casing, of course, and we have a GPS logger and a data recorder, a second pressure sensor just in case the first fails, and a nice light sensor that's going to tell us how much light gets blocked from the sun as the moon moves across. And the idea here is we'll take these, and we've got partners across the country, 6 individual locations, including Erie, and we're going to put these across the country like so. And then we're going to record the data that they actually produce. So the shadow will travel across each one in turn, the eclipse occurring earlier down in Texas, and then finally at our Niagara Falls site. And then we'll get all of that data: pressure, humidity, wind speed, light level. All of those things will come back to us, and then we'll be able to analyze it and see if this thing exists. We tested this out on a small scale with only 2 units, so we know they work. Nick Conklin took one down to Texas during an experiment he was running there, and on October 14th took some readings. So on the one side, you can see the annular eclipse of Texas here, and on the other side, you can see the partial eclipse. We weren't expecting a lot from the partial eclipse in Erie, and we got even less than we expected because it was raining and very, very cloudy. And the wind was such that I was concerned that it might knock the tripod over. So we did take readings because it was important to try and mesh those readings and see what we would do with our final data. But here is the actual unit sitting at the boat dock at Walnut Creek there. And as you can see, it's absolutely covered in water. So it works great in the rain, which is an important thing. And that means that even if, and I get this question a lot, what if it's cloudy? What if it's raining? Even if it's cloudy, even if it's raining, we will have a response to this eclipse, and we will have something to do and something to say about it. And that's partially why I decided to do such an experiment. So we're not essentially defeated by poor weather. This was the response in Erie. This drop in light level here around the partial eclipse might be due to the partial eclipse. It may also be due to extra cloud. It could also be due to dog walkers who enjoyed stopping and talking to me about the experiment, which I didn't mind. Once I said, don't touch the light sensor, everything was great. But that was the Erie results. The results from San Antonio were a lot nicer. You can actually see, if I boost this up a little bit, you can actually see a significant drop in the light level, and we can see drops in the temperature, drops in the wind speed, and drops in the humidity here. So this proved that those experiments work, and it's going to be really, really interesting to see what happens with the 7 units that we're fielding. As I said, they also record wind speed, they also record the wind direction, and this is the graphs of those. Erie was very much just west. So in terms of the participants, as I said, we've got our participants. It doesn't take much. They get their anemometer package in the mail. They're on the line of totality. They point it north, and then they enjoy the eclipse because all they have to do is switch it on and then switch it off, repackage it, and send it back. And it was designed to be simple. And this is one of the great things that has come from this is we've been practicing with these on site. We've been calibrating these. We've been working with them and taking them to various places around the Erie area. And actually, people have been responding well to seeing those out there. Here's all the various sites that we actually have. We're looking at Plano, Texas. We're looking at Little Rock, Arkansas, Doniphan, Missouri, Indianapolis, Indiana, Erie, PA, of course, and this is now an international experiment because it's Niagara Falls, it's in Canada, and it counts. It counts. It's in Canada. So we're calling it an international experiment now. So we will get data from all of these various locations. But as I said, going on site has been an interesting experience. We've been going out and calibrating our telescopes, calibrating our weather sensors, and people have been seeing us out there to the point where we decided, rather than constantly answering questions about what institution we were from and what we were doing there, we took my truck and covered it in hazard tape and put physics research vehicle along the side of it. And that explained a lot of things to a lot of people without us really having to start from scratch. And this got a lot of attention, a lot more than we expected. We actually gave out eclipse glasses to people as well on site and talked to them every time they asked us what it was we were doing. So we got a really nice public response, and what was supposed to just be essentially getting our scientific systems ready and getting our research ready actually turned into a really nice outreach tool as well. So that's our research. That's the eclipse. What else are we doing? And this is now that my research devices have been sent out and everyone's going to receive those in a day or two. This is the part I'm really working on, finalizing our outreach, getting everything together. During these eclipses, people love to get together. They love to have eclipse parties and view them together and experience the spectacle of this total eclipse. This is the 2017 eclipse. From St. Charles, Missouri. I was working at the University of Missouri during the 2017 eclipse in St. Louis, and the totality did not go through St. Louis. It went through St. Charles, just south of that. And I learned a lot of things about how the public respond, how the local area responds, and essentially how to really present the eclipse to people during this particular event. And this is people really enjoying the total eclipse. The sky does not go the color that is shown in the slide. The sky didn't really come out so well, but the eclipse is actually what I'm pointing to in the sky there. We have our website. We have a very good website. One of the best that's out there. I would even go as far to say in terms of the information for Erie. You don't have to dig through the NASA websites and try and find everything you need. If you go to the Gannon website that's listed here in our About Gannon 2024 solar eclipse, you'll find all the information you need, at least for the Erie area. We've tried to make it very centric to downtown Erie and the surrounding areas for people around here. The QR code that is actually on our Eclipse glasses even links to our site. So when we give glasses out to students, we give glasses out to school students and people on the street, then they can actually link to that and they can see our information. And that site is up. It's been up for quite a while now, for nearly a year, and you can find all the information you need there, how to see it from Erie and all of our safety information. But that has been our big message, has been eclipse safety, has been viewing this eclipse and making sure that you're not injuring yourself. And I would say this has been the message I've been trying to get across since the beginning. These things are spectacular. You need to be cautious, you need to respect them, but you also shouldn't be afraid of this. Some people feel like the sun is especially dangerous because there's an eclipse right now. This is not true. It's never a good idea to go out and look at the sun, ever. Just usually on any given day, most people are not compelled to have a look at it. This event, as I said, starts at 2:02 and technically finishes at 4:30. Now, this is something I want to get across, is the media say the eclipse starts at 2:02. They're correct, but people go outside at 2:02, put on their eclipse glasses, look at the sun. You can't tell the eclipse has started at 2:02. They then go in the house and do something else and miss the spectacular event that happens at 3:16. The totality, the bit you really want to see, is that bit at 3:16. And that's the bit you don't need the glasses for. All of the partial parts leading up to that, from 2:02 to 3:16, and then from 3:20 to 4:30, those parts you need these glasses for. And the only reason you need these glasses is for curiosity. How far through is this eclipse? There's nothing to be gained from really staring at this event for 2 hours. And I wouldn't even advise that even through these filters. We have developed what I would call eclipse windows here at Gannon. I've tested these at multiple wavelengths. They're not that difficult to build, but we are keeping it kind of to ourselves about how to build them so none of the public injure themselves. These have been tested at UV, infrared, visual wavelengths, and they are safe to use. We'll be using these at the Children's Museum. We'll be using these on campus so that anybody here enjoying the eclipse with us won't actually need glasses. You could use these windows and you can view the eclipse without the need for putting restrictive glasses. We will have telescopes set up. These will be properly solar filtered telescopes. We have all the proper filters, all the proper equipment that we can use to show you telescopic views of the eclipse as it happens. All the partial phases, we'll be putting it out to a monitor as well. And in terms of our venues, we're going to be using the McConnell Stadium here for the Gannon community and guests. We're going to be doing a public outreach and hopefully for some of the Gannon community over by the Arch next to Waldron, by the Chick-fil-A there on the Friendship Green. We'll have a telescope set up here, and we'll have viewing windows. Over here at the stadium, we'll have 4 telescopes set up and 2 windows, at least 2 windows. And over here, a sort of Perry Square area, one site by the Children's Museum, another one in conjunction with the Children's Museum in Perry Square itself, will have our eclipse windows, because these are really aimed at making sure children can enjoy the eclipse safely, because they have a tendency to grab those glasses, pull them off their face, and damage the filters. And we don't want anyone suffering any eye injuries during the eclipse. We've been working with Visit Erie, so we can do our outreach, so we can work with the public. I'm sorry, this slide has come out slightly strange here, but as I said, it's safe to observe the total eclipse, just the totality, the 3 minutes, 42 seconds or so from downtown Erie. Don't use anything else during the other phases. The rest of the phases, you're going to want to use those eclipse glasses that I was showing earlier. Don't use other things. Don't stack up sunglasses. They're not strong enough. People have asked me, can they use CDs? No, no, you cannot. Even darkened glass, things like that, these are not safe methods to view. Use a real pair of eclipse glasses. They're $1, $1.50, something like that. You can get these from country fair outlets. We'll be giving out the remainder of our supply on the day. We've been giving these things out to schools through IU5 as part of the initiative to make sure that every school child gets a pair of these glasses, but we will have some left for the day. If you don't get a pair of glasses, we have telescopes, we have windows set up. Some shades of welding glass will work, but they have to be very, very strong. And we're not really advertising that because we don't want people to get that wrong and hurt themselves. If you get a pair of solar eclipse glasses, the ones we have here at Gannon, I designed them. I pulled them out, so I know they're safe. I've used them and I've tested them, but they also have the ISO 12312-2 number on the inside of their frames, on the inside of the arms. If you have a pair that are not Gannon specific and are not ours, which I know are safe, then make sure you're looking for that number. That's ISO 12312-2. If you see that, then very, very high possibility that these are safe glasses. There was a question that came through that said, how do I test my glasses? Well, hold them up to a light, and if you see light leaking through, don't use them. If you don't see light leaking through, go outside, take a look at the sun, and then essentially if all you can see is the sun and there's no discomfort and you don't see any light leaking through, you're fine. But take a quick look at the sun initially. Take a glance. Don't sit and stare at it and then decide you're using a dangerous solar filter. Having a quick glance and then using it a little more afterwards is what you want to do. But there's really nothing to be gained by constantly staring at the sun, even through filters. Be careful. Some glasses out there that we're being sold from major online outlets that I won't mention were actually dangerous during 2017, but they didn't have the ISO number on them. So look for that number and you should be safe. The other thing you can do, we don't have a lot of leaves on the trees here right now. Maybe by April we'll have a few more, but you can always use a pinhole and you can always project the sun onto a surface. This particular picture was during the 2017 eclipse, and there's lots and lots of little eclipse shadows that you get under a tree like this during the eclipse, which is actually quite spectacular in itself and is a great way to view it. This is information that's on our website. This is what we're trying to convey here from 2:02 to 3:16. Use your glasses for this 1 hour, 14 minutes or so from the first contact when the moon hits the sun all the way to 3:16. Make sure you're filtered. Take them off. Enjoy the eclipse for your 3 minutes and 42 seconds. Then get those glasses back on and see the rest of the eclipse from 3:20-ish to about 4:30. There are these timings for local areas. They're not very different, but if you are in a slightly different area around Erie, then all of these are on our website and you can take a look at them, and it should tell you how long your totality will last and roughly when it starts. This is for kids. but it's a good rule of thumb for anybody. On April 8th, 3:16, the total eclipse can be seen. At 3:20, you've seen plenty. So that means get your eclipse glasses back on by 3:20. Additional information, we will be having the news outlets here talking to us about the eclipse, be it cloudy or not cloudy. They will be here. And during the eclipse, the Gannon radio station WERG will be sending out a recorded message, deliberately recorded. We talked about doing it live, but thought, what if we get distracted? So we have a recorded message that will tell you when to take those glasses off, and then conservatively, not right up to the second, conservatively, when to put them back on again at the end of the eclipse. So if you're worried about getting wrapped up in the moment and potentially getting a flash from the sun damaging your eyes, honestly, you just look away. It would be no worse than really driving into the sun, but it wouldn't be good to really look at that. The timing will be put out over our radio station to tell you time to put your glasses back on. But basically, I'm here to support people. Our website is there. If you have any more information, we do have a form that you can fill out on there. A lot of people have booked visits with me through that form. Unfortunately, my schedule is very, very full right now. So trying to find space to accommodate any more visits is not impossible, but very difficult. So bear that in mind. But if you have any questions at all and they're not answered by our website, feel free to communicate with me. I hope that answers everyone's questions and gives you a nice primer for the eclipse.
Dr. Horne, thank you for an incredible amount of information. To our alumni, thank you for hanging in there and for being part of this presentation tonight. You certainly turned out, and I hope you are as excited about the upcoming eclipse as we all are on campus. A few things to consider if you plan on being in downtown Erie on April 8th. Be prepared, plan for traffic. The City of Erie website is estimating an influx of between, and this is a big range, between 60 and 200,000 visitors. So between 60,000 and 200,000 people could be in the area trying to view this amazing opportunity. We will be at McConnell Family Stadium along with Dr. Horne starting at 1:30. Again, if you're in the downtown, stop by and say hello. Pick up these approved glasses that Dr. Horne has set aside for our alumni. Of course, we'll have drawings and baskets and fun prizes for our alumni. So we encourage that if you're looking to find a spot in downtown to watch with us. As Dr. Horne mentioned, Gannon's award-winning radio station, 90.5 FM WERG, will broadcast the event, and you can also live stream that. So even if you're not in the Erie area, you can live stream and hear what's happening right on our campus from wherever you are. Again, thanks everyone. So much information. If you have any questions, feel free to reach out to us here at the alumni office, GannonAlumni.gannon.edu. Enjoy your evening.